Good morning, and I'm Dave Snyder, and this is the session on blockchain and the Internet of Things. My company, my consulting practice is 42 Tech Incorporated. Let me go ahead and share my screen and get those slides started. Again, my company is 42 Tech, and my background I'll be talking about a little bit, but those initials show an MBA, registered civil engineer, certified information systems security professional, and certified Scrum Master. It's very timely that we're having this talk. Just yesterday, Dilbert ran this cartoon about blockchain, and everybody seems to want to know a little bit about it, and I'm going to try and answer some of those questions, particularly as they relate to the Internet of Things. Just this past couple of months, Fortune actually gave it front page coverage as a topic. It's been a lot of talk about Bitcoin and financial technology, but I'm going to be focusing on some non-financial things, or things that only touch on the financial, especially things that relate to the Internet of Things. So this Internet of Things Industry Magazine had an article just this past July in which they were talking a little bit about some of the advantages of blockchain relative to the Internet of Things, and we'll be going into some of these things, especially the idea of provenance of devices in a specific network, and how these devices might actually be facilitated for peer-to-peer transactions. So from today's meeting, I want to explain what block technology is and how it works. Touch on the subjects of data provenance and data quality, which I think are very important, and also data security. And then some examples of how blockchain technology is finding its way into the Internet of Things. So I see a lot of potential here. Data security is something near and dear to my heart. I'll explain, my background and also where the data comes from, what its context is, and the quality of data. So my background starts back in healthcare. I worked in intensive care units doing respiratory therapy, and we had to get it right. Things were critical. The information you see there is from blood gas analysis. In those days, things were not internet connected. But then I moved on to environmental engineering, got my civil engineering degree, did a lot of field sampling, a lot of laboratory analyses, and then put together maps and studies based on those analyses. And we were measuring in the part per billion range, and data quality became quite important. Then about 20 years ago, I moved over into internet subjects, especially e-commerce, and data security became an important topic relative to credit card systems. And then over the past few years, I've also been very interested in what we call digital health, the idea of internet-connected remote monitoring medical devices, and either for monitoring or for treatment purposes. So in the upper left, that heart monitor used to be just showing in the room and maybe wired over to the nurse's station, but now we're finding those devices are connected to the cloud and available remotely, as are many of the other devices shown in the pictures. So patient monitors and treatment devices, environmental sensors, industrial controls, and of course other internet-connected things like point-of-sale devices. So data quality. We really want to think about whether we're collecting the right numbers, measuring the right thing, and are we measuring correctly? So for the right numbers, we want to have reliable knowledge about where that data comes from, who was running that machine, what were the conditions when it was when the data was collected. And then in terms of data quality, do we have the right accuracy and precision? Is it specific to what we need to know? And then from a security perspective, it's not just about keeping data confidential. It's about the integrity of the data so that nothing is corrupted or missing, and that it's available when you need it. Is my sensor data reliable? Well, it's certainly important to regulators these days, and this is an example from the Food and Drug Administration talking about data from medical devices. And in their world, data integrity is defined this way, and some of the words you're seeing actually fall into the category of provenance and quality. So let's start talking a little bit about how blockchain works, and then eventually we'll get around to how it relates to the Internet of Things. First of all, it's a distributed ledger instead of a centralized database. And in that ledger, and we'll talk much more in detail about what this means. We'll kind of go peel the layers of the onion as we go along. They're blocks of data chained together with cryptography, and I'll explain what that means. But what it means is it's almost impossible to make changes once something's recorded. And of course, Bitcoin is based on blockchain technology, as are Ethereum and whatever other cryptocurrencies are out there. And no one believes that blockchain technology is appropriate for everything. In fact, that's a key question, is to decide, do you have a situation where it's useful? But in a lot of cases, it's likely that in the future, it's going to become like TCP/IP and public key infrastructure. These are the underpinnings of the World Wide Web, which many of us use every day, multiple times a day. And we really don't think about those technologies that are underlying it, but we wouldn't have the web without them. Similarly, we're going to have applications come that rely on blockchain technology, and it'll be invisible to us. Blockchain technology really only goes back about 8-9 years. Satoshi Nakamoto is the author of a white paper that explained how Bitcoin could work. No one really knows who this person or group is. A little mystery around that. In the long run, it doesn't matter. We've certainly seen financial uses dominate the discussion, and I just heard in the last day or two that the value of Bitcoin has gone up to $7,000 per Bitcoin. And a couple of years ago, it was trading at just a few $100s. So explosive growth in that. But I'm really more interested in things like supply chain and property records and smart contracts. And we'll talk about those. So again, distributed computing architecture. Every network node has a copy of the data. Only one block added at a time, and there is a mathematical proof on how that block was created and in what sequence. And there are consensus mechanisms, several different ones, but these are mathematical algorithms to make sure that all the nodes are kept in concert. And finally, strong cryptography is what we're relying on to make sure these transactions are maintained properly. So what are we getting? An unchangeable, or if you will, an immutable timestamp record of assets or transactions. This is key. It means that nobody can go in and erase something that's been added to the blockchain. With possible exception, there's what's called a 51% attack, which we'll talk about maybe a little bit later, but practically speaking, it's an unchangeable record. And everybody has a copy of the ledger instead of relying on a single vulnerable centralized database. It certainly provides a lot of auditability. And we now have the ability to do what are called smart contracts and some autonomous actions based on changes that occur. If certain data is recorded, it can trigger certain actions. So Gideon Greenspan is one of the leaders in the industry, and he put together a list of cases where you may or may not want to consider using blockchain. If you don't need a shared database, maybe a centralized database is fine. But if you need to have multiple people writing to the database, and there are issues of trust among the group, and you don't want to rely on a single central trusted intermediary like a bank to administer all of this. And finally, if you want to have some ability for interaction between these transactions, then blockchain may be right for you. Again, centralized databases, if they're properly protected, it's more confidential, only one copy of the data. On the other hand, if you've got a whole bunch of nodes with copies of the data, that's a more robust situation. So now I'm going to get into some of the technology. One way to think about this is you've got the infrastructure of the internet, and the blockchain protocol runs on top of that, and then we can have many applications that use this protocol. There is a website that goes into a little more detail on that. I'm not sure how easy that is to see on the screen, but if the infrastructure is in the internet layer, then the whole way that blockchain works is in the middle, and then you can have various applications on top. One of the very key things is the hash function, and if you're not familiar with it, if I have some text over here on the side and I run it through a hash algorithm, I'm going to get a 64-character hexadecimal representation that is unique to that file. If I make a tiny change, like removing one line or even a punctuation mark in that file, you can see I get a completely different 64-character representation. And it's a one-way function. So this is used in a lot of the security and reliability of blockchain technology. Again, I've been mentioning a distributed ledger. You can think of it as a bunch of computers, each with a copy of the database on it. And this is a representation of those blocks within a blockchain. And the little arrows are pointing, you'll see the numbers on the upper left. That is a hash of what is contained in that block. And if you go to the block 52, you'll see that that first proof of work hash is repeated in the second block. And that pattern continues. And each block is time-stamped. And if you were to corrupt one of those blocks, that chain of things pointing and being consistent would break. There's a really good YouTube video if you want to delve on that a little further. And you may hear the concept of Merkle trees. This is just a bunch of hashes of hashes. And the advantage that that gives in creating a block of transactions is that it's cryptographic proof of which transactions are in the block and the order that they're in. Another concept you'll hear about maintaining consensus among these different nodes in the network is the so-called Byzantine generals problem. Back in the day, without electronic communications, if you had armies distributed around a castle, you could send messages back and forth, but there would be some time delay, and you really weren't sure if all of your generals were on board with the concept. There could be traitors. And so it's a conceptual representation of the problem of how do you keep network nodes in consensus and not allow any bad actions. Well, mathematicians over the years have come up with what's called the practical Byzantine fault tolerance algorithm. We won't go into the math here, but it is one of the tools used to maintain consensus among networks. In Bitcoin, we have something called proof of work, and I'll show a little diagram on how that works. But basically, it's a very computer-intensive method, but it works great to have just anybody and everybody be able to get on the network and be a part of it. And in fact, they can earn a reward for helping to maintain the infrastructure. In Ethereum, there's something called proof of stake. This is another different way to validate that blocks should be added to the network. And there are others that are emerging. Key concept is that Bitcoin and Ethereum and a few others are public or permissionless blockchain ledgers. Anybody can join, and the trust comes from using these proof mechanisms to record for the way that transactions are recorded. I'm becoming more interested in private or so-called permissioned blockchain ledgers, where a controlled group of players get together and say, we want to be able to share some information. We can manage who's going to be allowed to use this with some basic identity and authentication management. Certainly financial institutions are looking at it, but industry is looking at this a lot. And this is where we start to think about Internet of Things. Getting back to Bitcoin, every 10 minutes or so, a block is created. It gathers transactions into that block, and then the miners attempt to solve a mathematical puzzle. We don't have time to demonstrate that puzzle here, but it involves being able to, how shall I say, come up with a unique hash that works to meet certain criteria. Once someone solves that, they publish their proof out to the rest of the network. The rest of the miners look at it and say, yeah, looks like he solved it. That miner gets a little bit of Bitcoin credit for it. The block gets officially recorded into the blockchain on everybody's node, and the process starts over again, creating the next block. So again, no central authorities needed to run Bitcoin. There's no, there are open source people who help maintain the definition of what Bitcoin is, but the actual network itself is not centrally managed. We have distributed ledger. The trust comes from how these blocks are created. In a case of cryptocurrencies, it prevents double spending. Hashes, of course, are part of what we're using to chain these things together. And again, proof of work, one or some other mechanism is used to maintain consensus. So let's start talking about the Internet of Things. After all, that's what this conference is about. And here's the stack that I'm starting to see more and more often as a way to depict it. Starting at the bottom, you'll have your devices out in the field and some sort of local connectivity, whether it's wired or wireless, into some sort of a gateway or hub, potentially some edge processing, and then internet connectivity up to a central server, the cloud. And on top of all of that, some sort of applications looking at that information. And the Industrial Internet of Things Consortium has a model that they show that shows data flows, and you've got your sensors off on the left, and then your users off on the right, and what they call a platform tier. And they also talk about the functional domains that occur in this paradigm, with your users off to the right doing various things. But I like to look at a really simplified model. If you've got a sensor out in the field in some sort of a local wired or wireless network, and then some way to connect it up through the internet just to your server and be able to do big data analysis on it. That's the model that, at least for a few years, has been out there. But with blockchain, you can get rid of that centralized server and have the information on a shared distributed ledger on a blockchain out in the world. And you can access that blockchain ledger directly to do your analytics. So let's look at another one of these models that has the sensors either individually connected or in a mesh, and then connecting through the cloud to a central server farm and accessed from tablets and laptops and so forth. And you can connect blockchain distributed ledger out at the edge, right at the gateway level. And make a mental note that later on we'll talk about an instance of solar panels on rooftops in a community. And really, it's happening out here at the edge. Doesn't need to go up to the cloud in order to have those devices talking with each other and interacting. Of course, you could also have blockchain up in the cloud replacing the central server, and you'd have your local devices, your user devices accessing data there. So what we've just shown is that blockchain in the IoT stack can really be applied either out at the edge or up at the centralized level. I say centralized, I mean at the cloud level. Now, another concept you may be hearing about in IoT is digital twin technology. And this is simply the idea of creating a virtual model of what's going on out there. Really, what we're starting to see is the idea that if you've got a digital representation of that sensor or controller out in the field on your blockchain, then you can do a lot with this to analyze, monitor, model, and so forth. So let's go a little further. And one of the first things to think about is supply chain. And indeed, this is one of the places where we sort of are using the digital twin concept. If you look in that second paragraph, the idea is creating a digital token, and it's a representation that every time the physical item, say whatever's being shipped, a shipping container or whatever, or a package, every time it changes hands, the digital token is moved around in parallel in the network. So we're mirroring the chain with a chain of transactions. We'll talk about a company that's doing that later. On top of this, you can have smart contracts. So for example, if company X is supposed to pay when something's delivered, you can have a device, an internet connected device on that package that allows you to know when it's arrived, and through the blockchain not only have a record of it, but trigger that payment to occur. And there's that solar power example that I'm going to be talking about later. So there's a lot of different use cases in finance, healthcare, distributing things, food and agriculture, manufacturing. Let's talk about a couple. We mentioned smart contracts. We mentioned remote medical monitoring. You can have soil sensors out in agriculture monitoring the humidity of the soil and deciding when irrigation needs to occur. Shipping data records, property records, manufacturing control, robots, and component tracking in a aftermarket situation. So we're going to have a lot of these devices. And we're going to be able to get away from broker-based networking and be able to use mesh networks where these devices will talk to each other without human intervention. They'll be able to identify and authenticate each other. And given the amount of data that these devices are going to be generating, I think it's going to be essential that we have this kind of automation. So one thing, when I was doing the research for this talk, that I was interested to find out is that IoT actually stands for the Internet of Tomatoes. And you may think I'm kidding, but there's actually a case where people are using sensors to capture data in the supply chain from seed to table. And all along the way, these different people who participate in that supply chain have contribute information to the blockchain record and have visibility into it so that at any point you can again see quality and provenance. Those are the words I was mentioning earlier. And in fact, Walmart has gotten into this in a big way. After a few of the food scares that we've had in recent years of contaminated packages, one of the leaders at Walmart brought his technology people into the room and said, if I put this package on the table and I ask you to tell me where it came from and how it was handled along the way, how long would it take you to gather that information and report back to me? And he said, and the clock starts now. And everybody scurried out of the room and started figuring out how to track down the provenance of that food package. And I think the report is it took 6 days. Well, they said that's not acceptable. And in fact, after they implemented a blockchain solution, they were able to cut that down to, I think, about 6 seconds, because it was all going to be recorded. You could bring it up on the screen immediately with the identifier on the package. And a lot of other food companies are now starting to get on board with this. In Boeing's supply chain for parts, like jet engine parts, they're giving all the different manufacturers and aircraft owners and maintenance people and regulators visibility into all of this. It used to be a very awkward process to have to request information, gather that information, send that information. And now, if everybody has access to the distributed ledger, they can see what they need to see. And you can control levels of access. We won't get into the detail of that, but because you're using cryptography and digital signatures and stuff and authorizations, you can manage all of this. So again, provenance. Where did the data come from? What was the context? And quality. Let's say we've got a sensor network connecting up to the cloud. And you can have a blockchain ledger to record that information and then have users be able to access that from desktops, laptops, tablets. Every time a sensor measurement comes in to the blockchain, it can be accompanied by information about that device and the context. And they can be recorded together in the block, and it becomes that immutable timestamp record, which helps support auditability. Similarly, calibration and completeness information about the data can also be recorded. And for security, we can think about the integrity aspect of that. And I was sensitized to this when working with point of sale devices that are out in grocery stores and what have you. Those devices are supposed to be locked down so nobody can tamper with them. And so you can imagine all these point of sale devices being out there where it says sensors. But let's say before those devices are deployed, we record some of the key parameters about that device. The software version, a hash of the firmware. Then, if any tampering occurs, at the time of use of the data, you can query back to that original blockchain ledger, and you can ask, has the signature of that firmware, has that hash changed? Oh, maybe somebody's tampered with this. Does it have all the patches it was supposed to have? If things don't match at the time of use, that is a red flag that something has happened. And the Open Web Application Security Project has identified a bunch of security issues that every Internet of Things application situation needs to address. And I've identified a few where blockchain can certainly be an advantage. That one at the bottom is the one I just described about having a hash of the firmware. So let's look at a couple of companies that are doing things with blockchain today. And I think when you get a copy of the presentation, you may want to look into these a little further. Tyrion is based here in Silicon Valley. They provide an API for anchoring data in the blockchain, so it's software as a service. Filament is up in Nevada, and they're working specifically with sensor networks, mesh network idea, and they even provide a way for those devices to be able to negotiate deals between them. So if one device needs to get data from another one, there can be a way to do that. GuardTime is a European company. They certainly provide a way to fingerprint data and record it in the blockchain. They have something called keyless signature infrastructure. It's being used in ID cards. And they recently won a contract to be part of a consortium that is looking to improve security and reliability for electrical grids, electric power supply transmission networks. Catenis is, I think, based in New York. They have a way of making sure that communications between Internet of Things devices are authenticated properly, and they rely on a Bitcoin infrastructure to do that. Chronicled is another San Francisco company, very involved in supply chain. They've done some interesting things with embedding microchips in some devices. For example, those expensive collectible sneakers. If there's an RFID tag in there and that is registered on blockchain, then you have a more confidence that that is indeed the product and not a knockoff. Here's the New York Times article about solar panels on a number of homes in Brooklyn. And there is a blockchain network working behind these so that if one home needs more electricity and another one is generating more with its solar panels, they can negotiate the transfer of electricity on their grid. IOTA is a consortium that is looking at some innovative ideas around distributed ledger technology. I mention it here in case people want to read up on it. The Institute for Electrical and Electronics Engineers, IEEE, is a huge international organization, and they have focused on blockchain in a big way. In fact, they have a working group on creating a standard for using blockchain in the Internet of Things that will likely tie in their other working group on the architectural framework for IoT. And there's also an international standards organization group focused on blockchain. And so we're getting pretty close to the end of the presentation. There is a Trusted IoT Alliance that is working on building a framework and some tools that will help enable the use of blockchain for Internet of Things applications. And you can see some pretty big names getting involved: Cisco, Gemalto, and then some of the local companies, SKU Chains, other blockchain supply chain company. Chronicle is in there, and several others. If you are going to be in Silicon Valley around the end of the month, there is a big exposition going on at the Santa Clara Convention Center. If you get a copy of this presentation or jot down quickly, here's a discount code for that. There are also free exhibit floor tickets available. Maybe I will see some of you there. So what we've done today is talk a little bit about blockchain technology and how it works. Talked a little bit about the concepts of data provenance and data quality and how blockchain can help support that. Looked a little bit at some blockchain use for the Internet of Things. Things I'd like you to remember is just the concept of the distributed ledger. Everybody's got a copy instead of a central database. Cryptography helps to provide an immutable timestamp record. Great for auditability. We can get smart contracts out of these distributed ledgers. And of course, we can do some computing at the edge with our local networks. So I'm going to go back to the chat window a moment here. Please recall that the services that I provide are generally in program management and product management for developing new products or implementing them or doing compliance work. And here's the link that will be available, and I'll also put this in the chat window. Someone mentions that IOTA, which was that project that I was wondering about, someone mentions that they got called out on rolling their own crypto by an MIT researcher. So it's early. We're on the sort of bleeding edge of this technology, so you definitely have to go in with your eyes open. How do you integrate the blockchain into the IoT? Would you elaborate further? Well, I'm not a coder, but you know, any data that you're ingesting into a central database right now can be ingested into a distributed ledger. So you would have to learn about how blockchain ledgers work, and then it's just a matter of when you're creating your get and post, how to send that to the right place. Question: is there an application of blockchain in the digital asset management field? I would say generally yes. I think that's part of what Chronicle and some of these other companies are really working on. The idea of either having an RFID or NFC tag on something, or there's even ways that they're talking about recording an identifier for a diamond and then being able to track that asset through the supply chain. And in terms of digital assets, I'm not sure what digital assets you're meaning, but certainly anything can be recorded. And if it's too large to record in a block, then you can record a pointer to something that's off the chain. Has anyone done benchmarks on blockchain performance, read-write ops per second, and scalability? Well, on the one hand, for Bitcoin, you generally want to wait on transactions to make sure that they've really been recorded and accepted. They say it's about a 10-minute cycle, but I've also heard things running slow up to 45 minutes. But that's just to get a block recorded, and you want to listen and watch for a number of blocks to be recorded before you are satisfied that your block really is in there and that transaction really is solid, and that can maybe be 24 hours. I'm not a Bitcoin expert, so take that with a bit of salt until you read up on it. In terms of other performance, it really depends how you structure the ledger. I've heard of a blockchain instance where you would have a more limited party. It's not, everybody in the world in a public permissionless blockchain, but it's a smaller network, and using some pretty sophisticated big data tools where they were able to ingest the Twitter feed into this blockchain just as an experiment to see how fast it operated. So it really depends on how you're setting it up and what your network is. Digital asset being generated by a device. Well, yeah, I think that's what we're talking about, is a piece of information gets generated by that device, and instead of having to go out to a centralized database, it's recorded in the blockchain, replicated across the distributed ledger, and because it is recorded in the block, there is I think, a unique identifier of that information. All right, another question. In private blockchain use cases, are things like proof of work as key as in public? In such cases, how is private blockchain any better than private distributed database where clients with appropriate authentication can access and update? I think it's a good question. Let's deal with the first part first. So proof of work, as it's done in Bitcoin, is a very sophisticated, energy-intensive process. In fact, there are whole computers and banks of computers dedicated to solving that mathematical puzzle. There are even application-specific integrated circuits that do that math. And these big server farms doing this tend to be located where sources of energy are low cost, which ends up a lot of it being in China, near hydroelectric power. But for private blockchain, I don't know all of the different consensus mechanisms, but you don't have to use something as powerful as Bitcoin is using. And is it any better than a private distributed database with appropriate authentication? Well, I think the power we're talking about in blockchain is that the way you're recording information in a block, think back to the hashing function and the Merkle tree picture. The way that things are being recorded is, once it's recorded, it's nigh on impossible to change. And so in a private network, you may still have various parties who trust each other enough to be together in the network, but they don't want to worry about somebody changing their copy and then claiming that they didn't get something delivered and therefore they don't have to pay, and that sort of thing. So I think that's the advantage of blockchain, is it becomes this record that everybody can then rely on once it's recorded and shared. Oh, there's one more question about advice for beginners in IoT field, and they say they're impressed by blockchain. Well, there's two parallel things: Internet of Things and blockchain. So let me make a note in here. For Internet of Things, there are increasing number of meetups and YouTube videos, and there's even some online classes through Udemy and Coursera and places like that. It's really helpful if you know some basic coding, some JavaScript, possibly some Python. Not essential, but it's looking like it's very helpful. There are things called Arduino kits. You can certainly learn a lot. They have very inexpensive sensors and boards and a coding language that's pretty easy to use to help do some little tabletop hobby projects to get familiar with it. Raspberry Pi is a similar thing. For blockchain, in the presentation and then on my website, I've got a few links where there's some interesting information about getting familiar. Coindesk.com has a very good set of tutorials, but there's actually a bunch of tutorials on YouTube. So I hope that's helpful. I think we'll call that a wrap, and thank you all for attending.